graphing exponential functions can be split into two types. One's exponential growth and the other one is exponential decay. Notice it's in the form of f of x equals a times b to the x power. X is in the exponent position. It's a growth if b is greater than 1, and it's decay if b is between 0 and 1, which makes sense because if it's greater than 1, this is going to be increasing, and if it's between 0 and 1, like a half, raising that to an exponent means it's going to be decreasing as x increases. The two general graphs look like this, and I think it's important to know the general graphs and play off of that when you get into graphing so you don't have to make a long table. Notice that an exponential growth is curved. It's growing exponentially. It's rising to the right. The slope is positive, and the particular parts of that graph are down below. X-axis is actually the asymptote. Notice why that's true. It's no matter what you put in for x, this will never reach 0. If you put in a negative 100, it'd be this number over 100, which means it's going to be a very small number. But again, this will never approach, this will never equal 0. Similarly, when you have a decay case, as x goes to infinity, this f of x will never be 0. Because it'll always be approaching 0, your f of x, however, it will not reach 0. And you have the particulars down below. Looking at two graphs, and when I'm looking at these graphs, I'm looking to see, well, first of all, is it an exponential growth? Is it an exponential decay? The first one is going to be a growth because of this is a 2. They're going to be increasing, so I know it's a growth case. Secondly, if you look at this, it's the same thing as e over 2 to the power of x. This is between 0 and 1, which means that you're going to have a decay case. Now, what I like to do is find out what the y-intercept is and draw the graph off of the y-intercept. So the y-intercept is where x is equal to 0. So when you put a 0 in for x, you're going to have 2 to the negative 1, which is 1/2. 1 plus a half is 1 1/2. Therefore, your 1 point is equal to 1.5 or 0.1.5. You know it's a growth case. And the second thing I like to do is figure out what the asymptote is. Now this number, regardless of how small you go with your x, 2 to the negative exponent is 1 over that number. And so that's going to reach a very small number, perhaps close to 1, but not reaching 1. So that means that there is going to be an asymptote at 1. So it's never going to reach that, but that's going to be where it's going to be approaching. So this graph is going to come down here and go up like this. And if you wanted to, you could have one more point on the graph to make this fairly easier to see. If I put in 2, 2 to the first power is 2, and therefore that's going to be 2 plus 1 is 3. So point here would be 2 and 3. And now you've got a couple points in there to see it, and that's all I would need to see that this is actually a graph with all the important parts. Now you could say, what's the domain? Domain is going to be all real numbers. The range are going to be all real numbers from 1, not including 1, to infinity. Intercept is only the y-intercept, 0, 1.5. Asymptote is going to be y equals 1. And behavior, as x goes to negative infinity, it's going to equal 1. F of x is going to equal 1. And as x goes to positive infinity, your f of x is going to be going toward infinity. And this is all going to be increasing no matter what point you put. If you were to draw secant lines, you are going to have a positive slope. Going to this one, this makes sense to put e's in your numbers instead of rational numbers. So when I look at and putting 0 in for x, your point here is going to be 0, and any number to the 0 power is equal to 1. So that first point is actually really easy. It's just 0, 1. You know it's a decay case. It's going to come down like this. And no matter what you put in for your x, this is going to get closer to 0 as x goes to infinity. So that means that it's going to come down like this and go up. And so you can draw in a graph that looks like this and see that you could probably put a couple more points in there. For example, if I had a 1 in here, then it's going to be e over 2. So that you could put in 1, and this point here you could put in has got to be equal to e over 2. There are a couple points in this graph, and again, you could answer these questions. Domain all real numbers, because your x's are all real numbers. Your range is going to be from 0, not including 0, to positive infinity. Intercepts, 0, 1. Asymptote is going to be the x-axis, or y equals 0. And behavior, if I go limit as x goes to negative infinity, that is going to be positive infinity, f of x. And if I go to positive as x's go toward positive infinity, my f of x is going to go toward 0. And in this case, no matter what point you choose, if you were to draw a secant, these are going to have a negative slope, which means it's going to be decreasing. So that's the general idea on how to graph a exponential